Hi, I'm Brian Freer, tutoring high school physics. Today's topic, gravitational potential energy and kinetic energy. Gravitational potential energy is something that happens whenever you have gravity. So everyone on Earth has some gravitational potential energy. Kinetic energy is the energy of motion. If any object is moving, it will have some kinetic energy. One thing before we begin, the law of conservation of energy. This states that energy cannot be created or destroyed. So what does that mean in terms of gravitational potential and kinetic energy? Well, if some object at some point is not moving at all of its energy will be gravitational potential. If that object begins to fall, all of that gravitational potential energy will gradually be converted into kinetic energy, as opposed to disappearing or being created. So at some point, all that gravitational potential energy will become kinetic energy. At every point in between, however, some of the energy will be gravitational potential and some will be kinetic. So now let's actually get down to business. How do we use this? Well, let's say we have a skydiver who tragically looks like a box. He has a mass of 80 kilograms and is suspended stationary at a point 20,000 meters above the Earth's surface. What's his gravitational potential energy at that point? Well, gravitational potential energy is equal to the mass times the acceleration due to gravity times height. So, a mass of 80 kilograms times a gravitational acceleration of 10 meters per second squared times a height of 2.0 times 10 to the 4th meters. So, 80 times 10 is 800 in kilogram meters per second squared newtons times 2.0 times 10 to the 4th meters. And this lands us 1.6 times 10 to the 6th Newton meters, which is, in fact, joules. Fancy that. Work and energy have the exact same units. Well, they are, in fact, related by this equation. Work equals the change in kinetic energy. So kinetic energy is defined as 1/2 times the mass of something times its velocity squared. So if you're changing the velocity of something, you're changing its kinetic energy. So if you want to change something's velocity, you would change its kinetic energy, and this equation would show you what the work you would need in order to do that. Useful equation, rarely used in physics though. Just keep in mind that there is a relationship, and this is it. Okay. So now, what is the skydiver's maximum velocity? We can use this relationship in order to determine that. So at some point, we have a maximum of gravitational potential energy. We just calculated that. He's completely stationary at 20,000 meters above the Earth's surface. At another point, he'll have his maximum kinetic energy. Note that this is also his maximum velocity, because you cannot have a larger kinetic energy value, and therefore you will not be able to have a larger velocity value. So, if we take this figure as the maximum energy, we can then calculate the maximum velocity. So, k equals 1/2 mv squared, and so our k, our maximum k, is 1.6 times 10 to the 6 joules, equals 1/2 times our mass of 80 kilograms, times our unknown velocity squared. So, nothing happens on this side. 1/2 times 80 kilograms is 40 kilograms, times our velocity squared. So we divide both sides by 40 kilograms, and we get 4.0 times 10 to the 4th meters squared per second squared. Isn't that neat? If we square root both sides, the meters squared per second squared is also square rooted and becomes meters per second. And we get a maximum velocity of 200 meters per second. Great. Now you can also use energy to find out its velocity in between the maximum and minimum velocities. So let's say that he is only 80 meters from the ground. In this case, we have our total energy, 1.6 times 10 to the 6 joules, equals our gravitational potential energy, mass, 80 kilograms, gravitational acceleration, 10 meters per second squared, height, only 80 meters from the ground, plus our kinetic energy, 1/2 mv squared, 1/2 times our mass of 80 kilograms, times our unknown velocity squared. Now we can get solid. So nothing happening on this side, boring, equals 80 times 10 times 80. So, long story short, that gets us to 64,000. Yes, and we have kilograms, 10 meters per second squared, that's newtons. Newtons times meters gives us joules. Okay. Plus 1/2 times 80 gives us 40 kilograms times our velocity squared. So you can subtract the 64,000 joules from both sides, and we get 40 kilograms times velocity squared is equivalent to 1.54 times 10 to the 6th. And still that's joules, so we're going to keep those. Now we divide by our 40 kilograms. And our v squared is 3.84 times 10 to the 4th. And so we divide out kilograms, so we get meters squared per second squared. And finally, we find the square root of both sides, giving us our final velocity of 196 meters per second. Quite close to the maximum velocity, but that makes sense since he's only 80 meters off the ground. Alright, to recap. Gravitational potential energy is signified by U and is defined as mass times the gravitational acceleration times height. Kinetic energy is typically represented by K and is defined as 1/2 times mass times velocity squared. A stationary object will have only gravitational potential energy, and a moving object will have kinetic energy. The law of conservation of energy states that energy cannot be created or destroyed, and so when something has maximum gravitational potential energy, that's the same as its maximum kinetic energy. And at any time in between, that maximum potential energy, which is the same as maximum kinetic energy, is equivalent to the gravitational potential energy plus kinetic energy. Note that work and energy have the same units, so work is defined as the change in kinetic energy. And so that means the work required to make that change in kinetic energy. Alright, that's all for now. Again, I'm Brian Creer. See you next time.